Okay, so in the last few classes, couple of classes, we have discussed how to derive the work done expressions for all the five processes, starting from isobaric, choric, isothermal, adiabatic, and polytropic. So all those things were done. Now, in this particular thing, we shall try to discuss other work transfers in the sense, apart from the PV diagram, there are many other type of work transfer. These are more like a mechanical work transfer. These are different forms of work transfer. You want to analyze the things. And this particular topic, the other types of work transfer, would be relevant only for this module number 2. So this will be nowhere continued further. That means the concepts of whatever you learn in the other types of work transfer will be only for the module 2, and it will not continue even in the module number 4 and the module number 3, but also in ATD also. It will nowhere connect you. So just have a gist of it. That's more than enough. And the questions on this will be definitely asked in the examination, so kindly concentrate it. The number one work is the electrical work. So electrical work, it's you already know that there will be a suitable resistance for the flow of electrical charges. Against this resistance, if current wants to flow, then you must provide a potential difference. And the current which flows through this is given by I is equals to dc divided by dt. Sometimes it is also called as dq divided by dt, where q is a charge. Okay, so that is all about the electrical work. Okay, if you want to calculate the electrical work, what you have to do is you have to integrate it. So integration at the end, the electrical work can be calculated as E into I. That is at which the rate of the work is getting transferred. So just remember this expression, that is more than enough. Okay. Next particular work, which is very important, which is known as a shaft work. So shaft work, almost all in all the cases you have used, it comes to use in the compressors, it comes to use in the engines, and various other devices where the rotation motion is preferred. And such a system will always have a torque, the amount of force which is acted, and the theta is the amount of angle which is rotated. The product of these two will be giving you the work, is it? Again, integrated, you will get the expression W is equals to T into omega. This is W is equals to T into omega, where omega is what? Omega is 2 pi nt by 62 pi n by 60. Okay, so this is the angular velocity. So that will be the work. This is how you calculate your work when the shaft is being rotated. Okay. Next is pedal wheel work. Pedal wheel work in the sense, if there is a system like this, okay, in this system you fix and fan. So if you go for the top wheel, there would be a fan like this, and this fan would be rotating like this. A pedal will be rotating like this. This causes the agitation within the mixture, and the work is being done in such a thing. So how do you calculate the work done? So the work done is calculated as dw is equals to mg into dz. Again, g into dz can be written as d theta. So that can be written as this particular thing. So just remember this expression, that's more than enough. So the pedal wheel work can be done in such a way. Next is flow work. This is very, very important. How many of you know the concepts of continuity equation? Whether the fluid mechanics and fluid dynamics part was there in your second PU? Yes or no?
Yes, sir. Yes.
So whether you have studied about the continuity equation, somewhere like this, A1 V1 is equals to A2 V2. To be more precise, rho 1 A1 V1 is equal to rho 2 A2 V2.
Bernoulli principle, sir.
I know before to the Bernoulli's principle. So when you go in depth into the Bernoulli's principle, which says P divided by rho g, v square by 2g plus z is always a constant. That is pressure, velocity, and atom is always a constant summation of those. Before you go into that particular aspect, you have to go with this aspect, and then you can derive the Bernoulli's equation. Hope you remember that. So let it be. And such a flow is being analyzed as a flow work, where the flow is given as what? The flow is given as P1 V1 P into dV. Amount of flow is just calculated thermodynamically, which is nothing but P into dV. That's enough. When you apply the same system, when multiplied by the mass flow rate, that would be P1, sorry, P1 V1 into dm1, which is in the change in the mass flow rate. Similarly, P2 V2 into change in the mass flow rate d2. Okay, so what is this 1 and 2? 1 is nothing but it is concerned with the flow which is entering the system, and 2 is concerned with the flow which is leaving the system. Okay, so just have a gist of it. If it can be asked in an examination, like explain the flow work for 4 marks, explain the flow work for 6 marks, or they can ask the multiple works in a single question. For example, explain the following works, 8 marks. Two questions would be there: electrical work, shaft work. You have to explain things. You have to draw, write some of the descriptions, you have to draw a diagram, and you have to draw some of the equations. Okay. Work done in stretching a wire. This is very, very important. Okay. So when there is a wire like this is studied in the mechanics, man. Okay. When you apply the force, there would be a change in its length, is it? Like that, it may stretch up. And this is nothing but your change in your length. Yes or no? Studied this in your mechanics? PL by A, all those formulas. Yes or no, man?
Yes, sir.
Okay. The same thing is being applied here. So what is the work done when you stretch a wire is being questioned here. So dW is equals to force into the displacement. That is always a criteria for the mechanical work. The mechanical work is defined as how? The force into distance moved. Similarly, here the force is the applied force and dl is the change in the length. So the product of these two would give you the work done here. In order to get it fully, you have to integrate it from 1 to 2. And you know that stress is given by force by area. Yes or no? The force by area, and even it is also given as E into epsilon. What is epsilon, by the way? Epsilon, this one.
Permeability.
Oh, permeability, why it will come in mechanics?
Right.
Epsilon.
Okay.
Epsilon is strain and capital E is Young's modulus, man. Your stress by strain is your Young's modulus, right? So that is how we have got this. So you can, because you have written here, see. Young's modulus is stress by strain. Now, the modulus of elasticity, which is Young's modulus of strain, which is given by dW is equals to dl divided by L. So you know this particular thing from which you have taken here. The work done in stretching a wire is given by minus F into dl, minus just because to compensate for the elongation. Okay, substitute the value of F from here. So it is E into epsilon into A, L into D epsilon. D epsilon is the strain. Okay, but after integrating, you would get this expression, okay, where it says W is equals to minus AEL divided by 2 epsilon 2 square minus epsilon 1 square. Just remember this, nowhere it is used in the problems nor in the entire BTD, but they have asked couple of times to derive an expression for the work done in stretching a wire. So it is very easy. Just have a note of it. Do not leave at any cost during the examinations. It might be asked. Stretching a liquid film. So what is the surface tension? How many of you know about surface tension? What do you mean by surface tension? Yes? Okay, man. I'll explain you what is surface tension in a minute now. So this is a water bath like this. Okay. So, in this particular molecule which I have drawn here, it is attracted evenly by all the molecules in and out of it. That means the forces which are experienced uh, is the evenly distributed force. This particular molecule here is being attracted evenly across its boundaries. That means it experiences no resultant force. But for a molecule which is at the surface level, what happens? It is attracted by the molecules at the surface, but there are no molecules in this particular region here. Yes or no? There are no water molecules. Only these are attracted by the molecules which are below it and at the side. This creates the tension in that particular molecule, so which is no surface tension. This is all just for the knowledge purpose, man. I'm just sharing that things with you. So in order to measure the surface tension, you'll be using this wireframe like this. And even in this wireframe also, the wireframe will be placed on the liquid film like this. You can even stretch this wireframe using a force, using a knob. There will be a knob there. You can stretch it by a force. And what is the work done in such a situation is given by W is equals to minus integration of sigma into dA, where sigma is nothing but the surface tension, which is always Newton per meter, not meter square. Keep this in mind. It's just a general things you have to keep in mind. It would be helpful for your interviews also. Next is the magnetic work. Magnetic work is given by the product of two things. The number one is magnetization U and external field strength H. So the product of these two will give you the magnetic work. These were some of the other types of work you have to remember and will be asked in the examination. Any doubts in this work? Any things more to be discussed in this? Yes? Nothing more to be discussed?
No, sir.
Okay. Now, this is very important, the heat transfer. Okay, heat transfer. How many of you know the heat transfer? How many modes of heat transfers are there? Yes. How many modes of heat transfers? Heat will be transferred from one substance to another substance precisely from a higher temperature region to a lower
Conduction.
temperature region. Excellent, Khalil. So, what is the first one? It's the conduction.
Conduction, sir.
Very good. Second one,
Convection and radiation.
convection and the radiation. Very good, man. I am happy.
Convection,
Yeah, Anish Pinto. Hmm. So conduction, convection, and the radiation are the three different forms of the work transfer. We shall see what is conduction. We shall see what is convection and radiation. Before to that, if there is a system, guys, I want everyone to answer this. If there is a system like this, if work is done by the system, if the work, I'm talking about the work, not the heat, if the work is done by the system, then it is positive or negative. If work is done by the system, whether it is
Positive.
positive or negative. Very good. So it is positive. Similarly, if work is done on the system,
Negative.
so work is done on the system is negative. Now I will be talking
Negative.
about the sign conventions of heat, guys. Okay, you are very much familiar with the sign conventions of work. Now let us deal with the heat. Suppose heat is added to a system. Okay, what I am doing here, I am adding heat to a system. Heat addition. Should I take it positive or negative according to you? I'm adding heat to a system. The energy is being gained by the system. Should I take it positive or negative according to you?
Positive.
Very good. Okay,
Negative.
okay. It should be taken as positive because your system is
So why
gaining
it
the
is
energy.
positive, sir?
Khalil?
Why it is positive,
Why
sir?
it is positive? That's what I'm explaining now. If a system is there, okay, if you are adding a heat to a system, inevitably the system is gaining energy or losing energy. Khalil,
Gaining,
whether
gaining.
if you it's gaining energy. If it is gaining energy, it should be taken as positive. Yes or no?
Okay, sir.
In the another manner, in another fashion, there is a system from which the heat is getting transferred to the surroundings. In this particular Khalil, in this particular case, the system is transferring heat to the surroundings. In this particular case, whether the system is gaining the heat or losing the heat. Anish Pinto. Anish.
Yeah, sir.
So in the system where it is transferring the heat from the system to the surroundings, in this case, in this particular case, I'm asking whether it is losing the heat or gaining the heat.
Losing.
Okay, so conclusion notice if the system is gaining the heat, yes, Pinto. If the system is gaining the heat, then it should be taken as positive. And if the system is losing the heat, then it should be taken as negative. Any confusion in this sign conventions of heat? When should it be taken positive, Narendra? Narendra Naik.
Gains heat, sir.
Huh?
When system gains heat.
Uh-huh. When system gives heat and system gains heat and it is not if it
Gains ಹೇಳಿದ್ದು.
ಗೇನ್ಸ್ ಹೇಳಿತಾ ಓಕೆ ನನಗೆ ಕೇಳಿಸುವಾಗ ಅದು
ಹೌದು ಸರ್.
ಇದಾಯ್ತು ನೆಗೆಟಿವ್ ಯಾವಾಗ ತಗೊಳ್ತೀಯ ನರೇಂದ್ರ ವೆನ್ ಯು ಡು ಯು ಟೇಕ್ ಇಟ್ ಆಸ್ ನೆಗೆಟಿವ್
When it gives heat, sir.
when it gives
When
the heat
system
or
gives.
it loses the heat from the system then it is taken as negative simple when it gains the heat then it is positive when it loses the heat then it is negative keep this in mind. Now, how many of you are in position to explain what is conduction? Let me see.
Transfer of heat in solids.
Transfer of heat in a material by
Excellent. So,
molecule.
within the molecule. So, in a simple sense, I can put forth as it is molecule to molecule heat transfer. The heat gets transferred from molecule to molecule. Suppose there is a break in this molecular chain like this, there is a gap in between the molecular chain, then the heat will be restricted here itself. It's never get transferred. And such a process is known as a conduction process. Coming to the convection, so what is the difference between the conduction and convection? First of all, how the convection process happens. What do you mean by convection?
They move molecules.
Mhm.
And all.
Your voice is not clear. Okay. Okay, I will try to explain the convection process and give you the comparison between the convection and the conduction with this particular example here. Kindly look into it. Now, see, there is a molecule here, and even there is a molecule here also. Okay, this particular molecule will not travel, is it? Whether it gets traveled, whether this particular molecule here will travel here and give heat, that is not possible. The molecule is at its own place, but because of the touching action between the two molecules, the heat gets transferred like this. That is the conduction. But what happens in the convection is your molecule literally moves like this, comes to a heat source. It comes to a heat source and then gets heated, and again it moves away.
Absorbs energy.
Got the meaning, guys? Got the meaning?
Yes, sir.
So that is what happens in the convection. So where do you observe this convection? Generally in the fluids, yes or no? So if there is a heating source like this, and the liquid is filled like this within the beaker, okay, the film or the layer which is exactly above the heat source, what happens? It's first get heated up. Okay, this first gets heated up and this moves away, and moves away, and the colder liquid will rush below. Again, the process gets repeated. Thereby, the exchange of heat is accompanied by the movement of the molecules, and such a heat transfer is known as a convection heat transfer. Any doubts in this?
No, sir.
Okay, now let us discuss about the radiation, guys. Now I will be discussing about the radiation. So what is the radiation? The beautiful part of radiation is, any guys know what about radiation?
It doesn't require any medium for its
Absorbing
transfer.
energy, absorbing energy and giving back.
Emission of electromagnetic.
Excellent, Narendra. It does not require any medium to transfer. Very good. I'm really happy for you. Can you add on, Anish and Aditya? Can I just add on what Narendra said? Any extra points?
Generated from emission of electromagnetic wave.
Excellent. It is rather I can put it in this way, Aditya. It can get transferred through an electromagnetic waves, right? So as Narendra said, there would be no medium whatsoever required for the transfer of heat. According to Aditya, what happens? The heat gets transferred in the form of electromagnetic waves like this, and most preferably it's infrared rays. Okay, kindly have all the basic science in your head. Okay, starting from radio waves, microwaves, infrared, visible light, x-rays, gamma rays, all those things has to be there in your head. So infrareds are the heat carrying electromagnetic waves through which the radiation can occur. The speciality of the radiation is it does not require any intervening medium to carry the heat from one substance to another substance. Just because of the electromagnetic waves, the heat gets transferred from the one to the another. So this is all about the conduction, convection, and the radiation. And you'll be having a separate subject on this, which is known as the heat and mass transfer, that you will detailedly study about how the conduction is happening, how the convection is happening, and what are the different parameters in it, calculations in it. Very, very beautiful subject, which is known as HMT, heat and mass transfer. Hopefully in the next semester, you'll study about that. Okay, where was I then? These are
Sir, radiation does not take place in medium, sir.
medium, even it can takes place in the vacuum also. Medium is not unnecessary for the radiation heat transfer. Okay.
Okay.
So all these things which I have just explained you now are being given in the form of the theory here, like this. Okay, if you just go through, you can get that. Okay. Sign conventions of heat. I have, yes, man, whether the work and heat are point functions or path functions.
Path functions.
Why it is a path function, Pratik?
Because we can calculate the area and
Yeah, so in order to calculate in order to calculate what is work and heat, you require the area as indicated here. You can see you require the area below it to calculate what is work and what is heat. If you want to calculate the area, definitely you require a path. You cannot calculate with a point, right? Point cannot calculate your area. So that's why these two functions are the path functions, which can be asked in the examinations again in the module number 2 to justify that how work and heat are path functions. You can explain the same thing with this particular figures here. Okay. The comparison between the heat and work, we shall see what are the different. We have studied the work, we have studied the heat. Now we shall see the comparison. Can anyone just read the statement number 1? Comparison.
Both heat and work are boundary phenomena.
So
Both heat and
both heat and work are boundary phenomenon. That means both of this will takes place at the boundary of a system and surroundings. So the work transfer or the heat transfer will occur only at the boundaries. That's why the term is a boundary phenomenon. Second point, Aditya.
both heat and work are transient phenomena.
Transient phenomena. Spell it.
Transient phenomena.
Transient phenomena. What does a transient mean? What do you mean by transient?
Transferable.
Transferable. Okay. Yes, pretty much it is transferable is the right meaning, but it is accounted for the time. If you change the time, if you increase the duration of certain things, even the
Short
magnitude of
period.
the work, yes, even the magnitude of the work, even the magnitude of the heat will vary. And such a phenomenon, which is time-dependent phenomenon, are known as a transient phenomenon. Okay, number 3, other than Aditya, anyone. Number 3, point number 3.
Both both heat and work are path functions and inexact differentials.
I
They
think there
can be
is no
written as
explanation.
integral of
I think there
sorry
is
sir.
no explanation required for this, right?
Yes, sir, yes.
Next, they
They
can be
can
written
be
as
written as
integral of.
integral of product of intensive property and differential
And
change of an extensive property. That is, both heat
see
and
how
work are
beautiful
thermodynamic.
this sentence is.
Sorry.
Yes. So how? Yes, yes, yes. See how beautiful this sentence is. You can just see it. They can be written as what? They can be written as the product of. Suppose the work is nothing but the product of an intensive property. Intensive property in the sense which is independent of the mass. I can take it as pressure, and the differential change of an extensive property. Differential change of an extensive property in the sense d into v, where v volume is your extensive property. So all the pdv works which you have calculated will be of such forms, even the pdv displacement work also. Hope you remember this equation, right? Work done is nothing but p into dv with an integration on it. Yeah.
Yes, sir.
So that is how they are. Both of them can be written as such. As of now, you will be not be knowing how to calculate Q visit. I will say you Q is given by integration of T into Ts, temperature into change in entropy. Okay, we will analyze all this in the coming future. So both of these can be written as what? They can be written as the integral product. The integral C, integral product of intensive property and the differential change of extensive property are just a beautiful sentence. Next, we shall see the, what we can say. We have seen the comparisons, right? Now we shall see the differences between these two. Okay. What are the difference between these two? First is the sign convention. If the work is being taken by the system, if it is work done by the system, then it is positive. If its work is done on the system, that is negative. But when coming to the heat, if your heat is gained by the system is positive, heat lost by the system is negative. So first thing you can write it as a the sign convention. Second one, can anyone just read? Rajat, Rajat is Medival.
Yes, sir.
Second point, man.
Can cause use of fall in temperature in an adiabatic system
Yes,
work and heat cannot affect the temperature adiabatic system.
because in an adiabatic system, heat cannot transfer, is it? What is an adiabatic system? Adiabatic system is a system where heat is, the change in the heat transfer is zero. That is, dq is zero. That's why it is that. And next point, Ritzek. Generally, Ritek Lobo. No, this guy is not there. Sohan.
Yes, sir.
Sohan, next point. Generally, work transferred. We have already discussed about this. Okay. Fourth point to read. There are many modes of work transfer.
Sir, screen is not visible. Wait, sir.
Okay.
So 1 minute, I will leave and rejoin, sir.
Okay. Akash. Akash.
Yes, sir. Yes, sir.
Tupul is
Present.
not there. Akash.
Present, sir.
Yes, read me the fourth statement, which is this difference.
These are as many modes.
There are many as modes of work transfer as variety of forces.
Variety
So
of
work
forces.
transfers you have just analyzed, is it? How many types of work transfer? Shaft work, stretching a film work, stretching a wire work, flow work. Different types of works are there. It corresponds to number of forces. If there is a magnetic force, magnetic work can be calculated. Electrical force, electrical work can be calculated. But when it comes for the heat, how many heat transfers are there? Only three. That is conduction, convection, and radiation. That is what he says here. Without this, Akash.
There are any three modes of heat transfer, namely conduction, convection, and radiation.
Radiation. That's it. Okay. The last point. In a cyclic process, complete conversion of work to other mode of works or heat is possible. In a cyclic process, complete conversion of heat is impossible. When it accounts for a cyclic process like this, okay, you can transfer your entire work into heat or other forms of work. Okay. Work can be completely transferred into heat, but your heat cannot be completely transferred into the work. This is the final difference between these two. Any doubts, guys? Any doubts till
No,
now?
sir.
No, sir. No, sir.
Understood? All those were theoretical concepts. I think 227 Sakmarana. Exhausted?
ಸಾಕು sir.
Sakmarana. So from the next class, we will continue again. Okay. Sir, can you send the PDF of this notes? Definitely, I'll be sending you once this model gets completed. Okay, even the real gases also. Give your attendance, guys. Abdul Rahim. Abdul Rahim. Meanwhile, you just look into this equation which I've just shown while you answer it, and just have a look. That's enough. I will discuss about it in the next class. Abdul Rahim, Akash, Ratesh, Bharatesh, Devdarsh.
Present, sir.
Okay. Next is Harshit. Harshit. Hashir. Hazim.
Present, sir.
Sujan.
Present, sir.
Kiran Kumar. Kishan Kotian. Hashir is present. Okay. Lucky Chaman.
Present.
Malatesh. Malatesh, not there. Milroy, not there. Mervin Pinto.
Sir, can we leave?
Once you have given your attendance, you can leave, man. We'll meet up in the next class. Mervin Pinto. Muhammad Khalid.
Present, sir.
Mohammed
Present.
Munawar. Mohan Chandra there. Okay. Muhammad Surai.
Present, sir.
Nishan. Okay. Nishtesh. Okay. Next is Numan. Deep. Praveen Suryakant. Raid. Okay. Raj Prasad. Rajat.
Present, sir.
Rajat. Okay. Rakesh Chiam. Ramachandra.
Present, sir.
Pratik Lobo. Syed Anwar. Sohan. Siddesh Piyan.
Present, sir.
Saurabh Shetty. Srinivasan. Stephen.
Present, sir.
Sujan. Okay. Vaibhav.
Sir, Sushant, present, sir.
ಸುಶಾಂತ್ ಎಲ್ಲೋ ಇದ್ದೆ
ನೀವು ಕರೀಲಿಲ್ಲ ಸರ್ ನಾನು.
ಹೌದಾ ಓಕೆಪಾ. ವರುಣ್.
Present, sir.
ವಿಘ್ನೇಶ್.
Present, sir.
ಮರ್ವೆನ್ ಪ್ಲಾನ್ಸ್. ವೈನ್. ಸ್ವರೂಪ್. Okay, Wayne is there. Swaroop is there. Chirant. Mendan Karthik. Darshan S. Shetty. Anish Pinto. Kat. Prakat. Not there. Praveen Nair.
Present, sir.
Abdul Sami. Aditya Shetty. Okay. Amal. Mervyn Lens. Amok P. Hegade. Wait man. Amok P. Hegade done. Chandan Rao P. Chirayu. Cyril Vikas. Abdul Sami. Given order man. Cyril Vikas. Darshan Shetty.
Present, sir.
Okay, pa. Cyril Vikas illa. Midlaj. Narendra Naik is there. Omar. Pratik Kesi. Okay. Pratik Kesi. Omar idhar hai. Rachan is there. Vitesh, Vishnu, Muhammad Khalil. Muhammad Khalil is there.
Present,
Vitesh
sir.
Kumar is there. Next is Vishnu Raj. Okay, pa. Take care.
Sir, yesterday told you that Sir,
Yes, Khalil.
yesterday told that you will explain us that 6 courses.
You have to remind me at the start, Khalil.
It's okay, sir. We will discuss in next class.
Just remind me at the class start itself. Okay, before I
Okay,
start
okay,
the
okay.
class, just give me a hint.
Okay,
That's
sir.
enough. I'll take it.
Okay. Thanks, sir. Shall I leave?
Yeah.
End of